Hello everyone, welcome to the Advanced Algorithm Challenges from FreeCodeCamp. Today we have the last challenge. Finally, cache register. Cache register is the most difficult challenge, also the heaviest in length. And it's basically that we have to program a whole cache register in JavaScript, and it has some built-in rules and some prerequisites, and it has all kinds of constraints. It's a bit tricky. We have several statuses. So we have open, closed, insufficient funds. So if they give us 20 and the subtotal is 20, then it's closed. We don't need to open the cache register because there's no change. If what we have left in the drawer is less than what we have to give as change, then it's insufficient funds. And otherwise, if we have to give a change and we have enough to give change, then we say open. So I have an array with objects that represent the exchange. So the exchange rates, so to say, with name and value, because we want to add them up. And we cannot do that with strings. So we need some kind of object matrix. So then we have three arguments: price, cash, and CID. Price is the subtotal, so what the whole groceries cost. Cash is what they pay us. CID is what is in our drawer, so the money that we can use to give change. Now we initialize a variable called cache register. It first has a status of null and a change of nothing. The change is gonna be the cash minus the price. So that change is an array because we're gonna give it out with the names of the exchanges. But we define another variable where we first calculate what is the change that we have to give. Then we do a sum of all the money in our cash in drawer. So if we do a console log at this stage, sum CID, then we get that number. So it is the total money that we have in the drawer. Then we reverse it. Actually not the sum CID, but the CID we reverse it because we want the higher numbers first and the lowest last. And we have a current value because we're gonna use it for the iteration. For this, we're gonna use the reduce method. With the reduce method, we can add things together or kind of join things together with an accumulator. So you might have already seen it being used for calculators. So when you add numbers up or subtract numbers from each other. So in this case, we have an accumulator. We also have the next value because we're gonna compare the next value with what we already have, and an index of the current iteration. So within that reduce method, we're setting the current value as 0. Then only for the final test case, which is this one, you return the cache even though it is 0. So here, if some of them are 0, just return them too, and otherwise just go over the whole change, compare if it is bigger or equal than the next value, than the value of the next iteration. And in that case, you are gonna loop over the change again, and as long as it is valid, the change is greater or equal to the value of the next iteration. And also for the cache in drawer, both must be higher than the value of the next iteration. Why? Because otherwise we can just return out of the reduce, and we are, let's say we have 1 penny, then we just return that penny. But if we have something like 6 cents or something like that, then we want to keep going and do a 5 and a penny. So the new change is gonna become the change minus the value of the next iteration, and we are rounding that to the hundreds, and we are also rounding the cache in drawer value, and same goes here as for the change. And after that, we are just adding that value, adding the value of the next iteration actually to the current value. So what we defined here. Like that, we are adding up all of the current values so that then we get a final number, so that then we get a final change. So we are reassigning current value to the value that we got from the reduce, so the current value array, and the accumulator, we're gonna push there the values that we got in an array. It's basically the next name, so the name of the next value, and then rounded up the value, which is the value of the change that we have to give. Then we return the accumulator, and otherwise we just return the accumulator. And then, yeah, like I said, there are 3 different statuses for the caching drawer. One is insufficient funds, one is closed, and one is open. Of course, you can do a switch statement on this, but I just went on and did an if-else statement. And of course it is complex, but most of the time it's just following the rules and trying to think, what if this happens in this case? Most importantly, you would follow the test cases and orient yourself on that, and then it would just work out. So thank you for watching. If you have any questions, post them down below in the comments. Make sure to like this video, subscribe to this channel. There's more content coming up. I am very glad that I've already finished the algorithm scripting challenges at FreeCodeCamp, and we got that JavaScript certificate in there. Of course, it's just a piece of paper, but it does represent that we at least know how to do JavaScript algorithms. Like I said, there's more content coming up, not only coding. So thanks for watching, and until next time, bye bye.